Hi, welcome to the Shiko Math Lab differential equation problem solving session. And here is the problem we are going to solve today. So y prime equal to y force cosine x plus y tangent x with the initial condition y0 equal to 1. All right, so like always, so here is the problem. The first things we need to do is let's try to examine this problem, see what could be the method we can use to solve this problem here. The first things here we observe is here. So this is the y prime, y force, and the y. Well, they are pretty good. They are all separate. So we know this is a linear, right? So now we are dealing with the trig function, the cosine x, tangent x. But in here, the function in front of the y's here, they are all just a function of what? They are just all function of the x. So we know this probably will be a good candidate for the Bernoulli equation. Okay, so now let's rewrite the Bernoulli. I always like to write the Bernoulli equation here when we solve it so we can reference. So we know that dy dx plus a function of x y is equal to the q, a function of x y to the nth term. So now we have the y and the y force both on the right-hand side of the equation. So let's try to rearrange it to remove it here. So here the y prime, I like to change it to a dy dx. Then move the y to the tangent x. So it's a minus tangent x y is equal to cosine x and the y to the fourth here. All right. So like now, if I rearrange it, then it will match my Bernoulli equation. So these things here will be my what? Will be my px. All right. And these things here will be my qx. And also, what is my n's here? My n going to be 4. So I know it's perfectly fit my Bernoulli equation. So as long as it is a Bernoulli equation, then we have a step-by-step method to do it, right? So the step number 1 is always the same step. So the step number 1, we defined a variable v is equal to y, the 1 minus n. All right, so 1 minus n will be 1 minus 4. So it's negative 3 because n equal to 4. Then I can rewrite it as what? 1 over y third. Okay, so now the second step after we do this, we can take the derivative of the dv. All right, so we say the dv dx is going to be negative 3 y to the negative 4, just the power rule, and the dy dx. So if you want to rewrite it, so this will be negative 3 y to the 4th dy dx, right? So what will be the next step? Next step is to find the dy dx. Right, so it's always the same step by step. Find the dy dx. All right, so change the dy dx to the dvx dy. So for this one's here, dy dx equal to dv dx. So what we can do is we can say, okay, in order to do that, let's just divide by. Okay, so this is the. So this one's here, I can just times negative 1/4 over 3, right? So I can cancel that out. If I times negative 1 over 3, so here I need to times negative 1/4 over 3 here. Okay, So after you do that, so that's what you got here. So this negative cancel. So this one cancel with here. So I have dy dx here. So then in here, the dy dx will just be what is negative 1/3 y to the 4th dv dx. Okay, so afterward, so the step number 3 is substitute the dy dx by using negative 1/3 1/4 dv dx. Okay, substitute to where? Substitute to. Okay, so it's a substitute to where I have here, right? So here. Okay, so let's substitute to my here. All right, so now let's do that. dy dx, this is dy dx. You see, that's why at the beginning I like to change y prime to dy dx so I can see better. So this is 1/1/3 y/4. All right, dv dx equal to minus the same things here, tangent x and the y. Nothing else change, right? So it's a cosine x y/4 here. Okay, so after we substitute here, then I want to simplify it to a dv dx differential equations here. So number 4 here, so step number 4 here. I go say it's always the same step. So I want to get rid of this term in front of the dv dx here, right? So now how do I get rid of these terms here? So what I can do is because so these ones here I can times the both equation right hand side and the left hand side with what is -3 y to the -4, right? So this is the whole equation. I can times this one to -3 y to the -4. All right, so let's take a look. So the first numbers here, -3, -1/3, 1. So these things cancel. So I will have a dv dx, right? And the minus. Okay, so this is a minus minus, so it's positive. So plus 3. Okay, so plus 3, then the y to the -4 tan x to the y, and is equal to cosine x y/4, and now I have negative. So the -3 y -4. Oh, I think I need to be careful here. Okay, so I forgot. Let me see. Did I miss some y/4 cosine? Okay, so y/4 cosine. All right, so dy dx. Okay, so let me double check because sometimes it is kind of like we need to be careful. So here, y/3. So find the dy dx. So substitute dy dx. All right, I'm fine. Okay, so I guess I am fine. See here, just don't want to make a silly mistake. See here. All right, after that, then we can see here, this is dv dx. And then here, this is 3 tan x. And the y/4 and the y, the y, so it's y to the -3. And then in here, the y/4 cancel. So I will have -3 cosine x here. All right. So that is what we try to substitute here. Okay, so now let's continue. I think differential equation is just very tedious. So sometimes we just need to be very careful. One negative sign, those things probably will sometimes will screw, throw you off. So here, okay, so let's say dv dx. Okay, then plus, I know the y negative 3 is the v's, right? So this will be 3 tangent x to the v and equal to negative 3 cosine x here. Okay, so now this is good. We change this to the simple, we finally change this to the simple linear differential equations here. All right, so this is the what is to go for the, this is the what the dv functions here. So let's highlight this one. So dv dx equal to the 3 tangent xv. All right, so after this, let's hope that everybody right now should remember what we need to do here. Number 5, we find the integration factors here. So integration factor, so we say du dx is always use du dx, then use my px, right? So what is my px here? This is my new px, so right? So this is my new px. Okay, so it's the same step. So this will be 3, 10, x. Okay, now what do we need to do? Times u. All right, so this is how we find the integration factor. So now I need to find solving for u here. Okay, so here, let's do this. So we need to resolve for u. Okay, so we solve for u, so we will have a du over u. I use a separation is equal to 310 x dx. Okay, so the left-hand side give you ln u, then the tangent x. Okay, so let me try to redo here. I hope everybody's remember. So the integration of tangent x here dx. We know that tangent is what is sine x over cosine x dx, right? All right, so now I use the u sub. I will say u is equal to the cosine x, then the du is equal to the negative sine x. All right, so the integration here will just be equal to the negative what? U du's here. All right, so that's why it will give me the negative u. So it's a negative cosine x. So that will be the ln cosine x negative, so it's a second x. So that's why this will give me just 3 in the front, and ln second x here. Okay, so this is the ln second x here. Okay, so now my u is equal to move this 3 to the power. So what is my u's here? The u will be the second cube x. So this is my integration factor. Okay, so now I remember like when we did it before, when we did the integration factor, then the next step is to substitute the integration factor back, multiply the integration factor back to my equation number 4 here. All right. Okay, so now after we find this integration factor, we need to insert, we need to multiply this integration factor to the equation I highlight in the pink in the 4, right? So I will do second cube. So basically I will do second cube x times the dv dx plus 3 10x times second cube x. and the v's here. All right, then my right hand side will be negative 3 cosine x, okay, and then times the second cube x here. All right, so here from the first things here, let's take a look. Let's simplify a little bit here. So this one, okay, so this one's here. So cosine and the second. I know the cosine and the seconds, they are the reciprocal of each other. So this term going to be what? This term going to change to the negative 3 second square x, right? Because the cosine and the second times each other will be once here. Then in here, these ones here, just like we did before, so this whole term will be second cube x times v, and you take the derivative of x here. So I always double check to see, make sure, I did not do anything wrong. So here you said by the product rule, second square, holding the second square, dv dx. Then hold the v, right? So hold the v here. Then take the derivative of the second cube. The derivative of the second cube is here is like 3 second square x power rule. Then you need to use the chain rule. So second chain rule is second x 10x, right? So that's why I match this term. So I know, oh, I'm good. All right. So that's what the so here now the number step. So what is step? And step number 6. Now I need to what step number 6. So after I change this, I need to integrate that, right? So here will give me the dx second cube xv equal to negative 3 second square x. Okay, so now I will integrate both sides. So left hand side will give me the second cube xv. Then the right hand side will give me negative 3. I know the second square integration will be what? 10x, right? So it will be 10x plus c. Now the v here is y cube, right? So we'll say the second xv is 1 over y cube. So it's 1 over y cube is equal to negative 3 10x plus c. Now let's plug in the initial condition y0 equal to 1. So, all right, so let's take a look at the y0. So second 0, the cube is equal to 1. So it's 1 times 1 is equal to, and then when you put the x equal to 0 here, the tangent x is 0, so it's equal to c. All right, so that's why we find our solutions here. C is equal to 1. Great. So now after that, I'll be able to solve my equations here. So number 7, I finally you can solve it. So I would say the 1 over y cubed going to be equal to, all right, so the second, the cube x, right, and then the top will be negative 3 10x plus 1. Okay, so if we want, we can flip. So the y cube just be second cube x negative 3 10x plus 1. Okay, and then the y cube will just be, you can take the cube roots, right? So if you take the cube roots, this will just be the second x. Then here, this will be negative 3 10x plus 1. to the cube roots. And oh, here. So after I take the cube roots, this disappears, right? All right, so that's it. And this is our solution here. Okay, so, okay, great. Okay, so like even this one, we have a cosine sine trigger function involved, but as long as when you observe the equation, if you see a linear and also those function in front of the y, they are all the function of the independent variable x or t, then you know you probably can use the Bernoulli equation methodology to solve it. All right, that's it. And I hope this one will help you to do your homework. Okay, so good luck and talk to you later. Let's work on the next one. All right, next time. Okay, bye. Have fun. Okay, bye bye.